So here's another guide video. Okay. So a tank has a height of 10 feet. The area of the horizontal cross-section of the tank at height h feet is given by the function a, where a of t is measured in square feet. The function a is continuous. So the function a is continuous and decreases as h increases. Selected values for a of h are given in the table above. Okay, so part A. Use a left Riemann sum with 3 subintervals indicated by the data in the table to approximate the volume of the tank. Indicate units of measure. So guys, you need to know that when you want volume, it's going to be equal to the integral of the area. Okay, that's volume. So the volume here is going to be equal to the integral from 0 to 10, okay, from height 0 to height 10 of a of h dh. Okay, so we are going to do a Riemann sum. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2, 5, 10. Alrighty, and then I'll say up here is 50.3, 14.4, 6.5, 2.9. Okay. 0, I have this output at 2, that at 5, this, and at 10, this. Okay, and it's a decreasing continuous function. Whoopsie. Okay. Okay, now the left Riemann sum, 3 subintervals. Okay, so this is going to be the base of the first rectangle. Left Riemann sum, if I wanted the right sum, I would go to the right endpoint of this base and then up to the graph and then complete the rectangle. But they want the left sum. So I go to the left endpoint, up to the graph, and then I complete the rectangle. All right, so for the height of the rectangle, you're using the left endpoint of the base. So the next base is here. I go up to the left endpoint and I complete the rectangle. And then this is the third base up there, complete. Okay. And as you can see, they asked if it was gonna, oh no, never mind, they didn't ask that yet. Okay, so this first rectangle, base times height, 2 times 50.3 is 100.6. Base is 3, 3 times 14.4 is 43.2, I already did that. And then this base is 5 times the height is 32.5. And then you add them all together. Math, no. 100.6 plus 43.2 plus 32.5. I got 176.3. So this is approximately 176.3. Now units. This is volume, so it's cubic units. So you could say cubic feet. Yeah, I'll say cubic feet. Cubic feet, or you could say feet cubed, that would also work. Okay, that's part A. Now part B. Does the approximation in part A, oh, you can't see it. Does the approximation in part A overestimate or underestimate the volume of the tank? Explain your reasoning. So you could see clearly from my picture that it's an overestimate. Overestimates. Now, but for the reason, you have to bring in something they told you about the function. And they told you here the function is continuous and decreasing. The case is that, guys, a left Riemann sum is going to overestimate if the graph is decreasing. So I'll say overestimates because A of H is decreasing. Okay, so that's part B. Now part C. So guys, those first two, oh, I should be telling you the points. Okay, so part A is 2 points. Part B, I think, is maybe 1 point. I should have looked. Okay, I want to start giving you the, like, how many points it is. I actually don't have the points in front of me, so I'm not quite sure. But parts A and B, guys, you could absolutely get. Now part C. The area, let me do this. Focus. The area in square feet of the horizontal cross-section at height h feet is modeled by the function f given right here. All right, so this represents the area in square feet of a horizontal cross-section 8 feet up from the bottom of the tank. Based on this model, find the volume of the tank, indicate units of measure. Okay, so this is part C. This you can get this also very easily. So remember, the volume is equal to the integral. In this case, we're going to go from 0 to 10, and then we want the area. All right, so volume is equal to the integral from 0 to 10. And then in here, you're just going to put f of h, dh. And then you've got to use math 9. Okay, so math 9. 0 to 10. And then in here, 50.3 over e to the 0.2 h. Okay, 101.325. 101.325, indicate units of measure. This is volume, cubic feet, or you could say feet cubed if you want. Guys, A, B, and C in the bag. Okay, you've got that. You could do it. Now for part D, this one is hard. It tripped me up. Okay, part D. Water is pumped into the tank. When the height of the water is 5 feet, the height is increasing at the rate of 0.26 foot per minute. Using the model from part C, find the rate at which the volume of water is changing with respect to time when the height of the water is 5 feet. Indicate units of measure. Okay, so, oh yeah. And guys, the units of measure, when they say indicate units of measure, what are we finding? Find the rate at which the volume of the water is changing with respect to time. So this is going to be cubic feet per minute. All right, so the units of measure are going to be cubic feet per minute because it's the volume. Okay, guys, so what do we know? We know that height is 5. Okay, at this very moment, we know that the height is 5. we know dH dt is 0.26 positive, okay? 0.26 positive because water is being pumped into the tank. So the height is rising. If water was flowing out of the tank, it would be negative 0.26. Alrighty, and now we want dV dt when H is 5, I guess? Okay. So they want us to use this model, all right? So this is the area. So basically, guys, we know that V is equal to, okay, so let's do V in terms of like H, I guess. So the integral from 0 to H, from 0 to H of, now this variable cannot be the same as this variable. Okay, these variables cannot be the same. So in here, I'll say f of w. F of w dw. Okay. Now, guys, this is from, if you go back to J18. All right, so we've got a formula. Formula to know. And this is from J18. You might not remember. But if you have f of x equal to the integral from some number a, g of x is up there, and then in here you have like, I don't know, I'll say h of w dw. And I'm not going to go into y, guys, because if you can see it if you go to J18. But to do the derivative, you take the derivative of this upper function, so g prime of x, times, you just take this input here and you replace the w with that top function. All right, so if you want to see why that formula works, which might be nice, it might help you to remember it, then just go back to J18. I think J18 through J21, we're dealing with that type of derivative. Okay, and guys, it's important to know that h is really a function of time. All right, so this is really h of t. So when you take the derivative of both sides here, you're gonna need to use this formula. So what we've got is that v prime is equal to, the derivative of h is h prime times now the inside function is f, and then instead of w, I'm putting h in there. Okay, and v prime is what we want. H prime is 0.26, and then at this moment, and then we want f of 5 equals 0.26 times, all right, f of 5, I go back, this is what f is. So 50.3 over e to the 0.2 times 5 plus 5. And then I'm going to type that in equal, I'm just thinking about notation. I think I'm fine. All right, so now I go 0.26 times 50.3 over e to the 0.2 times 5 plus 5. Is that the right answer? 1.694. I think it's right. Yes, it is right. 1.694. 1.694, and now we need the units to be correct. I don't know where I put, but this is volume. So this is going to be cubic feet per minute. Okay, that last part was very hard, but the other parts, you can do that if you're prepared and you've been working.